In our previous video, we solved an example on Fourier Sine series. Now this is another example, and we recall that in Fourier Sine series, our f of x is equals to summation of from to infinity of bn sine nx, and our bn can be evaluated as 2 over pi integral of 0 to pi of f of x sine nx dx. Now we can see in this question that our limit is divided into 2, from 0 to pi over 2 and from pi over 2 to pi. So we can split bn further to give us 2 over pi from 0 to pi over 2 f of x sine nx dx plus 2 over pi, and this time this will be from pi over 2 to pi f of x sine nx dx. So in this case now, bn is equals to 2 over pi integral of 0 to pi over 2 f of x. What is f of x when the limit is from 0 to pi over 2, which is pi, which is x? So from 0 to pi over 2, our f of x is x plus 2 over pi integral of pi over 2 to pi. The f of x between the range of pi over 2 to pi over 2 to pi, f of x is pi over 2 sine nx dx. So now let's focus on solving this. So bn is equals to 2 over pi integral of 0 to pi over 2 x sine nx dx plus pi over 2 will cancel 2 over pi and be left with integral of from pi over 2 to pi of sine nx dx. Now since we can see that bn can be splitted into 2, and this part here contains of u and v, so we will call that uv is equals to u v1 minus u prime v2 plus u prime v3, and it continues, where u is equals to x and v is equals to sine nx. So u prime, differentiating x, is give us 1, and u prime will be 0. So we have to evaluate v1 and v2. So our v1 is equals to the integral of v dx, and that will give us integral of sine nx, which is minus cos nx over n, and v2, which is integral of v1 dx, is integral of minus cos nx over n. This will give us minus sine nx over n squared. So we can continue solving our bn. That's 2 over pi. Since we are dealing with uv, we have u, that's x, v1 is minus cos nx over n, minus u1, u prime, that is 1, and v2 as minus sine nx over n squared, from limit of 0 to pi over 2. Thereafter, we have solved this part, and it's time for us to solve this part. So we are just integrating sine nx here, and that will give us minus cos nx over n from limit of pi over 2 to pi. So we can now continue solving by simplifying what is in the brackets. So we have minus x cos nx over n plus sine nx over n squared from 0 to pi over 2 plus minus cos nx over n from pi over 2 to pi. Now let's start with imputing the upper limit minus lower limit for the first part. So b of n is 2 over pi. The upper limit here is pi over 2. That's minus pi over 2 cos n pi over 2 divided by n plus sine n pi over 2 divided by n squared minus the lower limit, which is 0, minus 0 cos n into 0 over n plus sine n of 0 over n squared. Now we add the upper limit and lower limit for the second part with addition sign in between them. The upper limit is pi, and give us minus cos n pi over n. The lower limit is minus pi, and give us minus into minus cos n pi over 2 over n. Now to solve this, we will recall that cos n pi over 2 is equal to 0, and sin n pi over 2 can be equal to 1 minus 1 or 0. Okay, 1 in the sense that it can be sine pi over 2, minus 1 in the sense that it can be sine 3 pi over 2, and 0 in the sense that it can be sine 2 pi. Okay, also sine n of 0 is equals to 0. So with this, quite a number of things can be cancelled out. This contains cos n pi over 2, which is 0. This term is multiplied by 0, which turns to 0. This is sine n of 0, and sine n of 0 is 0. So this is 0. Cos n pi over 2. Cos n pi over 2 will be 0. So we are left with 1 and 2. So proceeding further, we have that Bn is equals to 2 over pi into sine n pi over 2 divided by n squared plus minus cos n pi over n. So Bn is equals to 2 over pi sine n pi over 2 over n squared minus cos n pi over n. Now take a moment and evaluate B1, evaluate B2, evaluate B3, and you can also evaluate b4. You can pause the video to do that. So after substituting your values of n, we saw that b1 is 2 over pi plus 1, b2 is minus 1 over 2, b3 is minus 2 over 9 pi plus 1 over 3, and b4 is minus 1 over 4. Now we recall that f of x is equals to summation of b of n sine x from n is equals to 1 to infinity. So f of x can be reduced to b1 sine x plus b2 sine 2x plus b3 sine 3x plus b4 sine 4x. Therefore, we can evaluate our f of x. Our b1 is 2 over pi plus 1 multiplied by sine x. Our b2 is minus 1 over 2 multiplied by sine 2x plus b3 is minus 2 over 9 pi plus 1 over 3 sine 3x, and b4, which is minus 1 over 4 sine 4x. Therefore, in conclusion, our f of x, which is the Fourier sine series, is equal to 2 over pi plus 1 sine x minus 1 over 2 sine 2x plus minus 2 over 9 pi plus 1 over 3 sine 3x minus 1 over 4 sine 4x.